Hello! In this video, I will demonstrate how Parasoft C++ test integrates into GitHub workflows. We are going to see how easy it is to create a GitHub workflow with C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub account to VS Code for convenient remediation. For the demonstration, we will need a GitHub account with a repository for the demo project, Linux workstation with Parasoft C++ test, GNU GCC compiler and Visual Studio Code, and a GitHub self-hosted runner configured for executing build and test workflow, which we will set up on the workstation. During the demonstration, we will go through the following steps. Create a demo repository in GitHub and add an example project to it. Prepare and configure the GitHub local runner. Define the GitHub workflow with the C++ test static analysis. And with all this in place, we'll simulate a simple use case with developer pulling the code, introducing changes using VS Code editor, and pushing the code back to the repository. Push operation will trigger the workflow with static analysis. Static analysis results will be published and available in GitHub for inspection and downloading to the local developer desktop. So let's start with creating a new repository for our demo project. I will switch now to my Linux environment. Let's log in using demo user username and PASS as a password. Now I will open the browser and create a new repository for our demo project. I will call it GHDemo. Now let's add some source code. We'll use popular timer project from C++ test examples. In the home directory, we have C++ test installed. Let me go inside and switch to examples/timer directory, where we have our example source code. This is a simple project we'll be using for our demonstration. Let's add this source code to our fresh repository and commit it. Great! We have some source code in the repository. We are ready to start development. The next thing we want to do is to configure the workflow, which requires configuring GitHub self-hosted runner. We'll use our demo machine as a self-hosted GitHub runner. Let's go to GitHub settings, select Actions, and then add self-hosted runner. GitHub displays a collection of commands for downloading and configuring the self-hosted runner, which we can copy from here and execute in our system. I will open a terminal and create a directory for the runner. Now let's download the runner and unpack it. Great, we are almost there. Now we need to configure the runner. Let's name it Demo Worker and proceed with the default settings. It is now configured and we are ready to run it. Great, our self-hosted runner is up, waiting for GitHub commands, and we're ready to define our workflow. Let's move back to GitHub and set up our workflow with C++ test static analysis. We need to click on Actions and then select Set up a workflow yourself. For our workflow, we'll use a GitHub action for running C++ test that is available in the marketplace. Let's type Parasoft in the marketplace panel, select Run Parasoft C++ test, and click here for more details. If we scroll down the action description, we'll find an example of the workflow that is pre-configured for CMake-based projects, which happens to be also used for building our example code. We can copy the entire workflow definition from the actions description and go back to our new workflow and just paste it. Before we commit, let's take a quick look. The workflow is pre-configured to run for main or master branch. We can modify it here to be also applicable for the feature branches. As you can see, workflow is prepared for the self-hosted runners. It uses CMake to build the code. Here we are telling CMake to emit compile-commands.json file, which will be used as an input for the C++ test static analysis. And once the code is built, analysis is executed with the run cpp test action. Action takes the compiled commands.json file generated by CMake and executes the static analysis. There are a couple of options that can be modified here. You can find more details in the actions description. We'll use the default values for our demonstration, which means that our source code will be scanned with the pre-selected collection of static analysis checkers called recommended rules. Once the code is analyzed, C++ test will generate a SARIF report, which will be uploaded to GitHub and presented as the code scanning alerts. We are ready to commit our workflow now. Let's add a short comment and commit the file. Our commit immediately triggered the workflow. Here, this small dot indicates that GitHub is executing the pipeline. Let's take a closer look. Here we can see steps or actions from our workflow being executed on our self-hosted runner, including, of course, static analysis with C++ test. Once the analysis is done, the SARIF report is uploaded to GitHub and the results are presented in the Security tab's Code Scanning Alerts view. Let's take a quick look at one of reported problems. Here we have a violation of the rule Avoid accessing arrays out of bounds. When we click, we are presented with more information. We see the place in the code where problem appears with a comment explaining the violation. If we click Show Paths, GitHub will present step-by-step path with code snippets and additional comments, which is a great help in understanding why and when the problem appears. C++ test integration with GitHub provides a great value here. Ability to review code scanning results directly in GitHub, either in the context of specific check-in or as a part of pull request, streamlines the development workflows and reduces the cost of the compliance process with industry standards. Now let's see C++ test GitHub integration from the developer's activities perspective. For this, I will clone the repository to my local workstation. Let me switch to the terminal. Since this is a fresh workstation, we'll need to perform the initial Git configuration. I'm going to configure now the username and my email. For development, we'll use Visual Studio Code with GitHub and C++ tests extension. Let me open it. As a first step, we need to clone the repository. So let's use clone repository and then clone from GitHub action. I'm already signed into my GitHub account, so I can directly select the repository. When working with a fresh setup, VS Code's GitHub extension will prompt you to sign in. Let's go with GHDemo repository It will ask about the location. Let's put it in the sandbox folder. We have successfully cloned the repository and we can open this folder in VS Code. The first thing we can do is to download the latest static analysis results generated in the GitHub pipeline. Let's use the C++ test VS Code extensions action to access the results from the latest pipeline. You may be asked to sign in into GitHub, but I'm already authenticated. And as we can see, all the results we could previously see in the GitHub are now downloaded to VS Code. C++ test extension automatically identified the latest results for our current branch. It's a great help and a time saver for developers. They are more productive when reviewing and remediating bigger batches of static analysis violations generated in GitHub pipelines without leaving their preferred IDE. So let's try actually to fix one of the problems. Here we have a violation of do not check for null after the referencing static analysis rule. This is an easy fix. I will modify the code now. Okay. Here we have another violation which we want to accept for now. So I can suppress it. I will enter the reason now. And we are ready to commit the changes and push them to the upstream repository. Naturally, it will trigger the workflow. Initially, we had 5 problems reported. Now we expect 3 problems because we addressed one and one was suppressed. If we go now to GitHub, we can see that the workflow is in progress. Let's give it a second. It finished. We can check the code scanning alerts now. As we expected, there are 3 violations only. Great. This simple use case presents the typical actions performed by developers when working with GitHub. In the real life, development process is likely to be more complex with a large number of feature branches and pull requests. C++ test GitHub integration is proven to support advanced development models. And this concludes my demonstration. Let's quickly recap what we have covered. We have discussed the procedure of adding GitHub workflow with Parasoft C++ test static analysis. We have used the GitHub Marketplace action for C++ test to configure our workflow. We have seen how static analysis results are presented in the GitHub interface. And we have also seen how developers can utilize C++ test VS Code extension and the GitHub integration to streamline their daily activities. Thank you for watching.